Today we're going to be talking about superposition and how to add electric forces together when you have more than two charged particles. Coulomb's law will only let you work with two particles at once. So what happens if we have more than two? Let's say we have three. In the example you'll see on the screen, we have three different charged particles. Particle number 1, 2, and 3. They're all in a straight line separated by certain distances. I also have the charge of each particle listed here. Charge number 1 is -6 microcoulombs, charge number 2 is 7 microcoulombs, and charge number 3 is 5 microcoulombs. So because charge number 1 is negative and charge number 2 is positive, they are going to be exerting an attractive force. So charge number 2 is actually going to be pulled toward charge number 1. Okay, and in this particular problem, we're wanting to know the force that's exerted on Q2, charge number 2, by charge number 1. So the force direction, okay, you see the little arrow popping up, the force between particle 1 and particle 2 is going to be pointing towards charge number 1. Okay, it's an attractive force. Now, the force between charge number 2 and charge number 3 is a repulsive force. So charge 3 is actually pushing charge number 2 away. All right, so what we're going to look at now, I'm going to go back a little bit in our video. Got a little ahead of myself. Okay, so we know that the charge or the force between Q1 and Q2 is attractive, and the force between Q2 and Q3 is repulsive. So now what we're going to do is we're going to find the value of each of those forces. So I'm going to calculate the force between particle 1 and particle 2. So I'm going to take K, my constant 8.99 times 10 to the 9, and I'm going to multiply it by the charge of Q1 and the charge of Q2. I'm going to divide it by the distance between those two particles. Okay, the distance between Q1 and Q2 is 8. So notice that I put 8 squared at the bottom because d is squared in our equation. Next, I'm going to find the force between charge number 2 and charge number 3. So I'm going to take K, Q2 times Q3 divided by 12 squared. 12 is the distance between 2 and 3. All right, so over the next couple of minutes, we're going to work through that math. So I'm going to plug in my numbers, 8.99 times 10 to the 9. I'm going to plug in my -6 microcoulombs. Micro is 10 to the -6. So I've got -6 times 10 to the -6 times 7 times 10 to the -6, all divided by 8 squared. So the force of charge 1 on charge 2 is -5.9 times 10 to the -3. All right, next I'm going to go through the math for the force between charge 2 and charge 3. K is 8.99 times 10 to the 9. I'm going to multiply that by charge number 2, which is 7, times 10 to the -6. I'm going to multiply that by charge 3, which is 5, times 10 to the -6. I'm going to divide everything by 12 squared. Okay, that's once again the distance between my two charges, Q and 3, Q2 and Q3. So the force between Q2 and Q3 is 2.2 times 10 to the -3. Once again, that is a repulsive force. So Q3 is actually pushing Q2 to the right. All right, once again, you can see that. We've highlighted that here. This charge is pushing Q2 in this direction. Charge number 1 is attracting Q2, so it's pulling that charged particle toward Q1. Right, so next, what we're going to do is we're going to use the net force equation. Okay, net force is equal to all of the forces in the x direction added together. So I have the force of Q1 on Q2 plus the force of Q2 on Q3. All right, so I'm going to take my two forces, I'm going to add those together, 5.9 times 10 to the -3, and I'm going to add that to 2.2 times 10 to the -3. All right, that's going to give me my total force that acts on charged particle number 2, Q2, 8.1 times 10 to the -3 newtons, and it is acting toward charge number 1. So when we go back and we look at our original picture, we have charge 1, charge 2, and charge 3. We knew that charge 3 was pushing charge 2 away from it, so it's acting to the left, that force, and charge number 1 is pulling charge number 2 toward it. So both forces are actually acting to the left. So your net force is actually pointing in the direction of Q1.